React Native developers, welcome to Can It Be Done in React Native. In this episode, we create some symmetry between SVG and OpenGL animations. Guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this week's episode, we are looking at the Darkroom color grading feature. The way it works is pretty straightforward. We have a picture, and for every color, every pixel has a color, and for every color, we apply a function. And here, you can see the graph of the function below. And you see we have a straight line that goes from 0 to 1 to 0 to 1. So we have fx equals x. So for every color, the colors stay unchanged. And moreover, you can see that it's a piecewise function, meaning that we have one function, we have 5 functions which are concatenated, so depending on the value of x. In OpenGL, a color is represented as a value going from 0 to 1. And here we have a piecewise function. If x is below 0.25, we have one function. If it's below 0.5, 0.75 and 1. So we have 5 functions total. And here, let's say, if we go for all colors which are between 0 and 0.25, I want to have fx equals 2x. So I would have something like this. So you can see now the function has been applied to every colors in the picture which are between 0 and 0.25. And you can see that it's actually a bit different than a straight line. So we have some smoothing between the points. So we have actually a concatenation of Bezier curves. And the way we do, so we have values which we can move here, and we create nice curves in between. And there are some strategies we can use to smooth, transform a series of lines into nice curves. So how would we do this in React Native? I am pretty excited because we love to do OpenGL shaders, we love to do SVG animations, and clearly here we have both things. We have a gesture which animates a sequence of Bezier curves in SVG, and we use these values to apply to animate an OpenGL shader. So we're going to display a picture as an OpenGL shader, and we know that we need to apply a function for every pixel, every color on the picture. And we're going to build 5 gesture handlers, one for each cursor, and it's going to help us to build a value that goes from 0 to 1. And then, so this is our bread and butter, right? Moving a gesture along the y-axis. And then we're going to use these functions to apply on the picture. In a previous Can It Be Done in React Native episode, the Rainbow wallet, we built in Redash all the primitives we needed in order to nicely create curves between points. And by the way, the work from Michael Ozdanik on the Rainbow wallet is open source, and we reused the code in Redash so that we can use it into animation threads. And we know also how to do the get y value for any x position. Here, the novelty is that we're going to use these recipes in SVG, but we're going to use them in OpenGL as well, in a shader. And in this episode, I'm going to show you something very cool where for some Redash function, I have the exact same function that is usable into an OpenGL shader. So if we know how to do get y for x on a Bezier curve in the animation thread, we know how to do it within the shader as well, and we get identical results. But what do you guys think? Can it be done in React Native? Let's have a look. And before we get started, one thing, if you're interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible animations that will run at 60 FPS, even on low-end devices. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. We are into VS Code here, and I have the boilerplate project, which you can download from the video description in case you want to code along. And we have the picture component. And what the picture component does is that it displays the picture as an OpenGL shader. So we have the picture, we get the aspect ratio. So we want to display the image entirely, and that makes it also easy to display as non-OpenGL shader because we know the aspect ratios are equal. So we don't have to do any complex calculation to display the image in the shader. So we simply map the XY coordinate to the source. Now the XY coordinate is the UV vector, and that is calculated from a vertex vector. We know because we have the varying keyword, which is used for shared values between the vertex shader and the fragment shader. Here, I only have a fragment shader defined, so I assume that there is a default vertex shader that is defined by GL React, which I'm using here, and I know I ran some debugging. I know that the UV value goes from 0 to 1 on the X and Y axis, and so top left is 0, like on the Canva, but the Y axis is inverted in compared to the Y axis on the Canva system of React Native. So here we simply map the color. So let me write, so here we have a color. So let me just write, a color is a vector of 4 values. So we have color. And we know that we need to apply a f function to that color. So I can write an f function, which returns, sorry. We have a color, and so we have color X, color Y, color Z, and then here for opacity we have 1. And we know that we need to apply an f function to every of these colors. So we apply f and I can write a simple f function which takes a value. So let's call it x. And we return some other value. And we know if we want the color to stay unchanged, we return x. So here the color is unchanged, but maybe I want to return 2x. So you see, all of the colors have been multiplied by 2. I can, and we know also that it's a piecewise function depending on the color value. So we have if, because it's divided by 5, so we have if x is below 0.25, we return something. But let's say here we return x every time. But we know that we're going to have a Bezier curve for every of these intervals. So x is below 0.5, we do something. Right? If we moved the cursor, the second cursor, first cursor, second cursor. If we move the third cursor, it's else if x below 0.75 and then below 1. And here we return 0. So now, for instance, if I want all the colors that go from 0 to 0.25 to go, to be 2x. Oops, sorry about that. So you see here I only modified part of it. So here I used GL React. My mental model is that if it's 2D, I use GL React. If it's 3D, I use React Fiber. You can do it, if you can do 3D, you can do 2D, right? So you can build the same example using React Fiber. And in fact, I know this for sure because I did it. I just like to use GL React for simple 2D shaders. And at some point I was, so you see this GL React, it does a lot of boilerplate for us. And at some point, I felt like it was doing too much boilerplate for me. I wanted to learn a little bit more, for instance, how I could set up the vertex shader myself and so on. And I was tempted, and I tried to build the example from scratch. So just using the WebGL API. And you can build simple shaders, but then like displaying an image and so on, things are getting like so crazy that I had to give up. And it's crazy that now WebGL, without a library, you have almost no chance to do something interesting. It's pretty crazy. So yeah, I used GL React. I wish I could build such an example from scratch, just as an educational tool, so I could learn better the WebGL API, but that was pretty overwhelming. So here we're going to build this F function. And the F function is driven by these 5 cursors, which we have here. So right now the cursor is empty. So let's create 5 animation values, assign each value to a cursor, and add the pan gesture handler so we can move these values from 0 to 1. So I'm going to create V1. And we have V2, V3, V4, V5. And we can pass it here to cursor. So we receive the value in cursor. And we can wrap this one into a pan gesture handler so we can move it around. Single child of a pan gesture handler is an animated view. This is an animated view. And we can write the on gesture event use animated gesture handler. And here we need the offset. So the first parameter is pan gesture handler gesture event. And we need in the context, so the context, which is a state that we can keep across gestures, so different events in the gesture, so is number. And on start, we store the value. So we have context.offset equals value.value. When the gesture is active, we need translation Y and the context. And we know that value.value is context.offset plus translation Y. But it's not translation Y, because if the translation is to 200, we want to convert it in a value that goes from 0 to 1. So we divide by height. Height is the height of the graph. So I have the constants file where I have like the height of the graph, the width, the stroke of the graph. And here, something I'm going to show you later. These are functions from Redash, which I rewritten as shaders. So here I genuinely copied this is the Redash code, which I just changed the syntax to compile as a shader. And here, so in Redash, we also have a representation for paths, which are sequences of Bezier curves. And I have a function called shader path, which converts the path object into a format that can be understood by an OpenGL shader. So as an array of vectors. So let me see if I need to import this one here. So divide by height, and we want to clamp between 0 and 1. So we don't want to go below and above 0 and 1. So 0, 1. So to visualize the change, we need to apply the translation. So I'm going to create an animated style here. Maybe I call it cursor. So we have, oops. Cursor is use animated style. And we return a transform. Translate Y. So it's value, value.value, but that we multiply by height minus half of the size of the cursor. So let's have a look. So you see here it moves nicely between 0 and 1. So our values are updated nicely. And now let's build a path, so a sequence of Bezier curves from these points. So we know that these points are updated nicely. And maybe also I want to update the default value. So here I would have 1, 0, 75, right? If we have x, fx equals x, 0, 25, and 0. So let's derive an SVG path from this as a path, not an SVG path, because we're going to use it in OpenGL as well. But so we will have path is use derived value. And we have a function from redash to convert points into curves. This function we took from the Rainbow Wallet open source code, but we just added the worklet directive so we can use it on the animation thread. Kudos to the team at Rainbow Wallet and more particularly Michalos Dadnik, who worked on these functions. So we're going to use, I think it's called curve lines. And our lines, so let me create points, which is simply V1, V2, V3, V4, V5. So we need to map the points into vectors. So we map. So I have the point and I. And so the X value. Okay, so we have some steps. So a step, we're going to divide the width of the graph. So we have 5 values, but so that would be, you see we have only 4 intervals, right? So divided by 4. So we have x is padding plus I times step. So 0, step, 2 steps, and so on. And the y value is simply point.value times height. So we go back from 0 to 1 to a value that goes from 0 to 8. And so that's the first argument. Then we have some anti-aliasing and the strategy of smoothing. Here we use complex. So let me see here, up, like this. So we have our path. Let's display it in SVG first, and then let's use it in the OpenGL shader. So in controls, I can assign path. So we receive path as parameter. So it's an animated shared value of, I'm going to call it repath, because it's a path from redash and not the path from the SVG component. So yeah, this one I'm going to call repath. So we receive it here, and we can display it. So animated props equals use animated props. We return D, and we simply serialize the path representation to an SVG path representation as a string. So it's path.value. So let's use the animated props. So we have animated path, animated props equals animated props. Stroke is white. We have stroke width, so we have the stroke constants. And let's have a look here. It should, yes, you see it makes a nice smoothing between points. So we have the path that we want. Now we simply need to use it within our OpenGL shader. So if we go back here, now we can pass path also to the picture component. So let me do that. So let me add it here. So animated shared value. It's a path animated from redash. Perfect. From reanimated. Path from redash. That's good. Just checking it's importing, because path can be also SVG. Animating can be from React Native. So I just wanted to make sure I have the proper imports. So we have the path. And we're going to pass the path as a uniform. So uniforms are values which can change over time. And here, every time we update the animation value, we want to redraw the shader. So let me create a function where we pass first the path as a uniform. I mean, here I can write path equals path.value, but we know this we need to update over time. And yeah, so I'm going to create a function called uniforms. So uniforms use callback. It receives path, so I'm going to call it P to not clash, path as parameter, and we return source and path. But it's not, we need to convert the path data structure that you see here into a data structure that can be easily processed in an OpenGL shader. And here I have the shader path function. Shader path here, I can pass the path as parameter and it converts. So we have C1, C2, C3, C4. So a data structure that can be easily understood by the OpenGL shader. So I probably need to add the dependencies here. And so I'm going to use uniforms and pass path here, path.value as. So we receive now as new uniform, so vector, an array of vector 2. So I think we would have vector 2 of C1, 4. And we have then C2, C3, C4. You see one for each step here. And now we can use, so if I go back to the constants file, we have these math functions which we can include. So that's what I'm going to do here. Oops. And these functions have cubic Bezier y for x, which is a copy paste from redash, which we can use here to solve x. So here we are going to use C1, C2, C3, C4. So we have C1, so C1, 0, C1, so the start point, right? We have 4 values, start point, control point 1, control point 2, 2 values. So C1, so control point 1, control point 2, and destination. And we do the same. Here it's the same, but with C2. C3. And C4. Now you see here the image is the same, but we need to update when we move the cursor, right? So we're going to listen to change on path. And there's many ways we can listen to change on path. Here I'm going to use animated reaction. And we check if the serialized path has changed. I think it's going to be fast enough, but there are other ways we can do it. Since we know that we can update one of the cursor at a time, we could also check, for instance, if the sum of all values has changed, that would trigger a change. But it wouldn't be much faster. I think here it's okay to do it like this. So serialize from redash. So if the path has changed, so we're going to redraw this one. So the node. So I'm going to need a ref to the node to redraw. And since we don't have the types for the node, we're going to use any. So use ref null, and I'm going to type it as any. I try to avoid using any as much as I can. In fact, it's forbidden, I think, by the... Why it's not complaining? It should complain. Oh yeah, because I have a syntax error. Yeah, you see now it's complaining, but for this particular use case, I will allow it. So we're going to need to redraw. So we're going to need to do node current, and I think it's called draw or set draw props. And we need to pass uniforms. Again, we're going to use this. Oh, but this is the UI thread. So we need to call back to the JavaScript thread. So we're going to do run on JS. And I'm going to call update. And we can pass the path.value as parameter. So let's do update equals use callback. We get p as parameter. And here we can do the set draw props. We also need the dependencies. And uniforms, we call uniforms on p. So let's see. Okay. And so you see here, the function gets applied to the shader nicely. Isn't that cool? So you can do, I don't know, you can try to revert. We can do all sorts of things. Guys, I hope you enjoyed this example. It was so fun to have an SVG Canva and an OpenGL Canva in the same example and to have symmetric functions that we can run both on an OpenGL shader and on the animation thread. I remember a couple of years ago with V1 to run Bezier functions, complex Bezier functions on the UI thread was very, very complicated, and I love that now these are not only trivial, but we can also have the same function running on an OpenGL shader, and we're definitely going to do more things related to OpenGL going forward with the series. Now, if everything goes according to plan, the next episode of Can It Be Done in React Native should really be special, so I am looking forward to talk to you soon, and until next time, happy hacking.